Okay, today we're going to talk about Chapter 6 functions and specifically Section 6.4, the library of functions. Now, this library is going to be something you're going to use not only in this class, but if you take Math 1400 as well, this is going to be a part of the library used there. There's going to be a little bit larger one, but you're going to use functions a lot in especially 1400 once you get there. So the library of functions is a set of functions that distinguishes the relationship between the function and their graph, which includes the domain for each function. So what we're going to do is we're going to kind of look at these. There's not really a lot of calculations. It's just kind of really looking at it and just kind of recognizing which function is which and kind of understanding where the domain and range are. So the first one we have is the constant function. Basically, that's some f of x is equal to c. Okay, and so the domain here basically is all real numbers, so no restrictions are on the input because we can plug anything in here for x. And since there's nothing there, what we're going to get out is the constant c, so that's the output. And so basically your range is a set c that contains a single element. So whatever your c is, in this case I'm going to show you down here at 2. And in interval notation, this is written, bracket c comma c bracket. So, the interval that begins both and ends with c. So this is kind of a general graph of what you're going to see. It's going to be some horizontal line, f of x equals c. So whatever c is, that's what point it is on your f of x. And your domain, basically, like I said, it's all real numbers. So from negative infinity to positive infinity, and your range is just basically from c to c. It's only going to be c. Now, if we had the function f of x equals 2, so no matter what x we put in, and I just put a few here examples, negative 2, 0, or 2, we're going to get 2 out. And so, when we plug in negative 2, we get 2. We plug in 0, we get 2. And we plug in positive 2, we get 2. And then we can draw our straight line, and that's how it's going to look. Now we have an identity function. Basically, we're having f of x is equal to x. And again, here, there's no restriction on x because no matter what x we put in there, it's going to work. And so basically, we're going to have both the domain and the range are going to be the set of all real numbers. And so over here, this is the specific y equals x. And you can see no matter how far down we go or how far up we go, it's going to still be on that line. And so x's are going to continue to go to the left and to the right. So the whole domain, negative infinity to positive infinity. And our range, which is the up and down, is going to go down to negative infinity up to positive infinity. So the range is also negative to positive infinity. Then if we plotted points on f of x equals x, again, if we plugged in negative 2, 0, and 2, we can see where they're going to end up, and then we can draw our line from that. If we could put more points, and they're still going to end up being on that line. Now we can also have a linear function, and basically this is any line y equals mx plus b where the slope is non-zero and there's a non-zero y-intercept. And basically you're going to have the same domain and range applied to the linear function as to the identity function. So, we could draw any line straight across here or, coming down. Now, if we had a slope of 0, that's going to be the constant function. So we're not going to have that. And we can't have a vertical slope here either. So it's going to be basically any line that you can draw besides the vertical and the horizontal is going to be your linear function. The next one we have is called the absolute value function. That's f of x equals the absolute value of x. And there's no restriction here on x either, because no matter what x we put in here, we can take the absolute value of it and get a value for f of x out. Okay, but because the absolute value is defined as the distance from 0, basically your output is only going to be greater than or equal to 0. So that means our domain is going to be from negative infinity to positive infinity. It's going to go no matter where we go on the x-axis, we can use it. But our range, it starts at 0 and only goes up because if we plug in a negative 2, the absolute value, that's positive. Plug in a positive 2, absolute value is positive 2. And that's an example here, kind of, if we do the negative 2, 0, or 2, you get out the absolute values, you get 2, 0, 2. And so plotting on an actual coordinate grid, it's going to look something like that. Then we have the quadratic function. That's f of x equals x squared. And so, we have quadratic functions, x squared plus 5x minus 2. We have to factor those. So, we know about quadratic functions. And here the domain is all real numbers, since the horizontal in the graph is a whole real number line. So no matter what x we put in, we can get out a value out. So we can plug in, negative 200, we can plug in 100 or whatever. It's still going to work because you're just squaring that number, and that's going to be what you get out. Now the key is your graph's not going to include any negative values because when you square something, it's going to be positive. And so the range is only going to be non-negative real numbers. So it's going to be from 0 on to positive infinity, depending on what you plug in for your x. So for example, here I plugged in some values just from -2 to +2 by 1. And so if you plug in a -2, you get 4. Plug in -1, you get 1. 0, you get 0. 1, you get 1. And 2, you get 4. And you plot that up, and it just keeps going up and up, kind of like this one here, and to basically infinity, going to the upwards value, and it's going to keep going to the left for negative infinity and to the right for positive infinity for our x. Then we have the cubic function. And here again, the domain is going to be all real numbers because no matter what we plug in for x, we're going to be okay. There's no restrictions here for what we have. And so the whole number line, domain from negative infinity to positive infinity. And basically, it's going to be the same thing for our range because no matter what we plug in here, we're going to get both positive and negative. So if we plug in a negative and we cube it, we're going to come out with a negative. If we plug in a positive, we're going to come out with a positive after we cube it. So our domain and range are both the same. And this is what it looks like. And how you kind of get those points are, and I only did 5 points here, but if you plug in a -1 and you cube that, you get -1. Plug in a -0.5, you cube that, you get a -0.125. 0 gives you 0, and then 4, and so on. And if we plugged in 2, you would get 8, and if you plug or -2, you get positive -8, and if you plug in +2, you get positive 8. And so on. And so that's going to be kind of how the general trend goes. It's going to look something like that. Then we have the square root function. So thinking about the square root, what can we take the square root of? Only positive numbers. And so therefore, our domain is going to be from 0 to the positive infinity. We can only do the positive. And so there's nothing going to be on the left side over here. And it's going to include 0 because you can take the square root of the 0 and it's 0. And so that's going to be the key. And then when we take a square root of something, it's always going to be positive. And so the range is also only going to be from 0 to positive infinity. So we're just going to be up here in the first quadrant. And so that's going to be kind of our general shape of the curve. So that's how we're limited to those items. And so we know when we plug in x, it has to be only positive numbers. So I start with 0, then I kind of do the ones you can make a perfect square root of. So 1 is 1, 4 is 2. And so those are some examples, and then it just keeps going out. If you did, 16, then it would be 4, and so on. So, but you could do the points in between too, but they're not as nice to actually plot on an axis. Okay. Then we have the cube root function. So, the cubed root of x. Here, the domain and range include all real numbers basically, because we're just picking some value to the 1/3 power. It doesn't matter what it is if it's an odd root. So because of that, our domain is going to be all numbers from negative infinity to positive infinity. And because of how that works, we're going to get the range also to positive infinity. Some examples here. So if we take -1 to the 1/3, that's going to give us -1. If we take that to the 1/3, or take the cube root of it, however you want to look at it, here we get -0.5. 0, of course, gives us 0. And then those give us the positive. So we go, from the negatives, and then we get up to the positive. So that's going to be what our cube root looks like. And here's our final one for our book here. And that's going to give us the reciprocal function, which is just 1/x. And so this one is going to give us something we have to think about. Here we can't divide by 0. We can't have 0 in the denominator. So we have to exclude 0 from our domain. Otherwise, any number else you plug in should work. And so how we define that is we go from negative infinity to 0, and then parentheses, because we can't include it, union from 0 to positive infinity. And when you do that, it's going to happen that the range is going to be the same thing. So our range will be the same. And because it can never go down to the axis here, and it can never reach here. And so those get close to the x-axis, and here it gets close to the f of x axis. And same thing on this side. And so basically your zeros are not there. And so what we can do is we can start plugging in numbers. And these are the ones that goes in. Again, you can't plug in 0, so you don't have to worry about that. And so when you plug those in, that's what we get out. And then we can plot our points. And again, you can plot more points, and that's not a problem. But plotting them to make it so it's easy to plot, that's the key. So you have to plug in ones that are kind of nice to do there. And so those are all the functions that we're going to use for kind of our toolkit as far as what we're looking at. Again, these are going to be more important, I think, when you get to your Math 1400 class. So, keep those in your mind if you have to take that class.